So draw a Venn diagram to illustrate the set A complement intersection B. The first thing we need to have a little review of is what are Roman numerals. Okay, so I'm going to write this on the side. I should scoot that over. If we remember or were ever taught what Roman numerals are, because we're going to denote the regions of the Venn diagram with a Roman numeral. So I know that an I is 1, right? I know that II is 2. 3 I's is 3. And then an IV is 4. And we're going to list through about 9. A VI is, I skipped 1. I skipped 5. V is 5. VI is 6. VII is 7. VIII is 8. And we're only going to do through 8. Okay? If you'll remember, you can only list the I's 3 times. And then you have to start subtracting or adding to a different letter, a different Roman numeral, okay? So that's where the IV comes from. V is 5, and if a lower valued letter, such as the I, comes before the next one, you're subtracting 1 off. So IV is 4 because that's like 1 from 5, okay? Then 5 add a 1 is 6. Add 2 1s is 7, 3 1s is 8. So if we want to, when it says draw a Venn diagram, we're going to start off with our rectangle that denotes the universal set, right? And then, so I've got my A, and I've got my B, okay? And then we want to label our regions. So we make this first one. We go left to right, and we start inside the circle. So we've got, that's region 1. Region 2 is that intersection. Region 3 is over here, just B. And then region 4 is the rest of the universal set. Okay, the things that fall in the universal, but they're not in A or B. Okay. Now, we want to illustrate the set A complement intersection B. So I kind of have you start off writing what's in there, and eventually by the time we get to the end of the examples, you guys can just look at the picture and tell me, but we start off. So right now, tell me who's in the universal set.
2.
4.
Yeah, 4. Well, now remember, universal set is all of them, right? So the whole universal set is 1, 2, 3, and 4. That's everybody, right? That's everybody in the set. No trick. There's no trick here. Okay? So who's in A? If I look at the whole circle A, what regions are in A? 1 and 2. Good. Okay. And what regions are in B?
2 and 3.
2 and 3. Okay. And like I said, the main reason I have you write them this time is so that you can see what I'm talking about. Okay? Because it gets really simple once you've done them several times. You can easily just see. Okay? So we want to find A complement intersection B. Well, you can find A complement real easily. You know A is 1 and 2, right? 1 and 2 are in A. What does it mean to be the complement?
Everything but that.
Everything but that. So who's left?
3 and 4.
3 and 4. So A complement is 3 and 4. We're going to do an intersection with B. Okay? Well, you know who's in B, right? We already wrote that. So I can go ahead. B has 2 and 3, so can you tell me who's in the intersection of A complement and B? What does it mean to be in the intersection? You have to be,
2. Oh,
Oh,
yeah.
it's just what they have in common?
yeah, just what they have in common.
So it's 3.
So just 3. Very good. Okay? Now, that's your answer as far as being written out. And they'll ask, yes, ma'am.
When we have the test, do we have to show our work or do we just?
No, you can just tell me the answer if you know the answer. The only reason I'm writing it all out right now is so y'all can make sure where I'm getting it from. Like it doesn't just look like it magically appears.
The test will be true or false, right?
No, false. We wish. So they'll ask you, at some point they'll ask you to shade it. So if you were going to shade it, all you would do is shade region 3. That shaded blue region represents A complement intersection B. And it makes sense because you're not using A at all, and you're using who's in the complement of A and also in B, right? We'll do another one. Okay. Example 2. We say draw a Venn diagram. And technically, diagram is not supposed to be capitalized. I apologize. To illustrate the set A complement union B. This time it's a union instead of an intersection. So we're going to draw our Venn diagram again because it says draw a Venn diagram. So y'all can't just look back. We're going to start, we're using A and B. So I draw my universal set, that rectangle there that contains everybody. Then I have A and B, and you'll notice my circles don't look great all the time. Okay? I'm going to label my regions 1, 2, 3. And then, of course, I have the part that's not in A or B is region 4. Okay? Looks just like the other one we drew. You can draw the same thing again. All the information's the same. Okay? U still 1, 2, 3, 4, right? A is 1, 2, B's 2, 3, just like it was before. We want the complement of A united with B. Well, I'm going to write down complement A. And so if I'm looking for the complement of A, if you don't want to list everything out like that, guys, you're literally, you just take your hand on your paper, and I want the complement of A, so that means I'm covering up all of A. Covering up all of A. Who's left? 3 and 4. So A complements 3, 4. Okay, you know what B is. Who's in the circle of B? 2, 3. And so you should be able to tell me what A complement union B equals now. When we do a union, all we do is what? Write down everybody that are in those two sets, right? Because when we do a union, we include everybody. Everybody joins together, okay? So that means A complement union B should be 2, 3, and 4. I don't write down 3 2 times, okay? You only have to write down once. He is in both of them, but he only counts as himself. And that's your answer. Y'all like, this is too easy.
You're right.
If you are to shade that, then you just shade what you wrote. We got region 2. Okay, there's 2. Region 3. Region 3 is included. And then region 4. So that's all around. And that makes sense, guys, because you united the complement of A, that's everything outside of A, with all of B. That's why you added on the intersection there. That's why it's included, because you threw in all of A. I mean, you threw in all of B. You threw in all of B with that complement, okay? All right. Let's bump it up a little. Example 3. Y'all like, knew it was too good to be true. Same directions. Draw a Venn diagram. To illustrate, the set A intersection B complement united with C. Uh-oh. We threw a C in there. Okay, well, we know what to do when it says draw a Venn diagram to illustrate something with A and B, right? So we know we start off with our rectangle. Notice I'm drawing a little bit bigger rectangle this time. And I know I draw an A, I draw a B, and I'm going to have to draw a C, and C goes down here at the bottom. So I have A, B, and C, because C is going to overlap A and B. That's my universal. Now, here's how we label those regions. You start inside the circles, just like we did with A and B, and kind of start, if you can imagine it, at the top part. So here's 1. Now this top little chunk of the intersection becomes 2. Can y'all see it? I didn't give myself enough room there. And then I go left to right, just like I was doing, and I make the B part by itself 3. Okay? So now I go to the middle, kind of in the middle. I make this chunk 4. I'm looking at all the different little intersections. This part 5. This part 6. That's my middle intersections. Then I go to the bottom and take care of 7 in the C. The bottom chunk of C is 7. And then those that don't live in A, B, or C are 8 out there. Oh, missing a line. 8. So I'm going to go ahead on this one, and I'm going to write out, we're going to write out the sets, okay, like we did on example 1, so that you can kind of see where things are, since we have 3 sets in there. Okay, so universal set, it's going to just be all the numbers, right? It's going to be all your Roman numerals 1 to 8. It's going to be whatever you labeled, correct? That's universal set because it contains everybody. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. A, can you look up there and tell me who's in circle A?
1, 2, 4, 5.
Good. 1, 2, 4, and 5. And that's kind of what I'm doing, writing it out, is making sure that you're seeing correctly, for lack of a better word. Okay? Who's in B?
2, 3, 5, and 6.
Good. 2, 3, 5, 6. Okay? And who's C then? C's nice.
5, 6, 7.
4, 5, 6, 7? Yeah. 4, 5, 6, 7. You see the 4? Okay? Good. Okay, so we want A intersection B complement first. That's who we got to find first, right? Because here's what we're looking for. This is what we're looking for right here. That's what it wants me to find. Well, I know what C. I'm going to start with the parentheses, okay? Remember how we always start with the parentheses? A intersection B complement. Well, I might need to know what B complement is then, shouldn't I?
Right.
So I'm going to write B complement up here. Well, I know B is 2, 3, 5, 6. So it's all the other numbers but 2, 3, 5, 6, right?
Exactly.
So 1,
4,
4,
7,
7,
8.
and 8. Very good. And see how much easier that is than what we were doing with the before with the list. When you have the picture, it's easier to see. To me it is anyway.
We're not done yet.
Oh, we're not done. That's B complement. Can you tell me the intersection between A and B complement? What is that?
2 and 5.
Look at B complement. Look at A.
Oh, yeah.
What do we got? A 1?
1.
Because remember, intersection is they're both there. 1, 4. 1 and 4. Are y'all good with that?
1 and 4.
Okay. So you've done the first part, and you want to do that A intersection B complement united with C. Oh, that's good. That's friendly. A union is what? We throw them all together. So I'm going to write down the 1. I know I got a 1 and a 4, right? And now I write down the C's. C is 4. Well, I've already written that. 5, 6, 7. There you go. Okay? If I need to shade it, and sometimes they'll tell you to, or they'll show you the picture, okay, and ask you. So we do 1, 4, 5, 6, and yes, I made check minuses in kindergarten because I couldn't stay in the lines. 6, 7. I got real check minuses on that cutting. She made me tell the story. Write the set illustrated by the Venn diagram. And it says the set is A. Oh, no. They give you, I nearly told you the answer. They give you the Venn diagram, and they want you to pretty much write the equation that makes it. And I'm going to tell you, I'm probably not putting anything like this on a test because it's not really fair and the answers vary. It's hard to go the other direction. Okay, so what they've done, but I do think you have something like this on the homework. Probably one. They give you this picture and they go, what is that? The part that's shaded. Write some kind of set using intersection, union, and difference. I can post it. I'll post it on YouTube. You don't have to. They want you to just go, okay, is this A union B union C? But you can use union, intersection, and subtraction. Okay, so what did it look like this was to start with?
A and C.
A and C. What of A and C?
Intersect?
The intersection. Good. So start off with that. A intersection C. So if I had A intersection C, it would be the whole blue chunk right there, right? Y'all are right. Then what did they do?
They added B. They
They-
took B away.
They took B away, and we do have an operation that takes away. We can actually subtract a set. We subtract B, and when you subtract B, then it makes your picture that you have there. And you're done. That's the answer. If they would keep them that simple, I'd put it on the test. I just don't know if they'll keep it that.
Yeah, if it
I-
was that simple, I know it was a trick.
Yeah, you would think it was a trick, and then you'd miss it because you thought it was a trick. Yeah. But that's all that one. That one was that easy. Now we have to know some things that I will give you these on the test. But they're kind of some rules that deal with sets. We call them De Morgan's laws. That's what we call them. And they start off for any two sets. A and B. A union B complement equals A complement intersection B complement. Okay? Now, you don't have to memorize that. And we spend the next 3 examples. Yes, at least 3 examples proving this law and the next one. And like I said, I will give you these, when you take your test, they'll be on a piece of paper, kind of like a formula chart that goes, these are De Morgan's laws. But more than likely, you're not even going to have to go, oh, pick from these. Which one's De Morgan's law? You don't have to do that, okay? We have more De Morgan's laws when we study logic. Is why they kind of start giving them to you. Okay, and the other one that we're going to talk about in here with set theory is if we take the intersection of A and B and take its complement, that's the same thing as uniting the complement of A with the complement of B. It's just showing you can write that either way, that those are equal. It's going to produce the same sets, the same regions. Like if we found A intersection B complement, and you told me what regions those were, if I went over here and united A complement and B complement, it would be the same thing that I got for the left-hand side. Okay? And we show that in the next few examples. Okay. All right, example 5. If U equals, okay, now we're not writing cities this time, but we are writing news stations. So this involves a little more writing. If U equals A, B, C, NBC, CBS, Fox, USA, TBS, TNT, and MTV. That's Elton. Yes. Elton, I'll mark you here. When we switch classes, I'll check you off on the attendance, okay? So, the universal set is ABC, NBC, CBS, Fox, USA, TBS, TNT, and MTV. Some of y'all have no idea what TBS, TNT is. You probably know what MTV is. But some of y'all don't know what TBS and TNT is because y'all just stream. And unless you have, like, TNT's old days, TBS is old days too. Like I said, y'all probably know what MTV is because you watch stuff on YouTube about when that where they had the.
Is that Turner Broadcasting?
I think so. I don't even know if it's still. Around.
MTV's still going.
No, I mean TBS and TNT. I don't know if
TBS
they're.
is still going.
Is it?
I don't think TNT is.
It may not be. I don't know. A equals, but it's okay. They're TV stations. If you still have any kind of satellite, you can get all of those with satellite, or if you have cable, they come with cable. Okay? A equals NBC, Fox, USA, and TBS. And B equals ABC, NBC, CBS, and Fox.
2 subsets.
So at least it's only 2. We want to find the complement of A union B and complement A intersection complement B. So pretty much that's which one of our laws there. It's, this law is our first De Morgan's law. You're proving it with exact examples here, with specific examples. You're proving, you're going to get the same thing. When we find the union, the complement of A union B, it's going to equal the same new stations as when I find the intersection of the complement of A and the complement of B. We're going to get the exact same new stations, is what it's trying to tell us, okay? So let's start off with the first one. We're going to look at A union B complement. Well, in order to find that, I got to find A union B, right? Okay. Well, A union B is pretty easy for you guys because all you do is write down everybody that's in A and everybody that's in B, correct?
Right.
So I've got NBC, Fox, USA, TBS, ABC, now I'm off to B. NBC I've already written down. I'm not going to write it down again. CBS, and I've already written down Fox, so I don't have to write it again. All I did was write down everybody that's in A and B. Okay, all those elements. Now I want the complement of that. Okay, and that's going to be my first answer. I know I go back up. You know what? Let's not go back up. Let me just...
CBS.
Okay, so I'm gonna do this, and then I'm gonna go back and erase it off there. You don't have to erase yours off there. I'm going to put a mark through who is A union B, and then who's left in the universal is the complement, right? So I know I need to take out NBC, I need to take out Fox, I need to take out USA, TBS, ABC, and CBS. So who's left? TNT and MTV. Good. Okay. TNT, MTV. Okay, that's your first answer. Right? Okay, then it wants me to find A complement, intersection, B complement. Okay, so it makes sense that I need to find A complement and B complement, right? All right, let's find A complement. So I'm gonna do my mark out method again. I'm looking at A, I'm gonna mark those out of the universal set. So I'm marking out NBC, I'm marking out Fox, I'm marking out USA and TBS. So A complement, ABC, CBS, TNT, MTV, right? Okay. ABC, CBS, and then who was it? TNT and MTV. Okay. B complement. Let's do the same thing. Let's mark out our B's. ABC, NBC, CBS, Fox. That one's easy for remember who to write down. It's just the N starting with USA, right? USA, TBS, TNT, and MTV. Okay, so you tell me now what is, I'm actually going to move that up. A complement, intersection, B complement. Looking for the intersection, so that means who they have in common, right? Who's it going to be?
TNT and MTV.
Good, TNT and MTV. You are exactly right. And did it turn out to be the same thing?
Yes.
Is my other blue one? Mm-hmm. And that was De Morgan's law, De Morgan's first law. So you prove that right here. Okay? All right, let's do, that was example 5, so that wasn't too bad. Let's do example 6, and it's going to use the same sets up here, our stations. You do not have to rewrite them, just make sure you can see them. Using the sets from example 5, we want to find A intersection B complement and A complement union B complement. So that is my second De Morgan's law, isn't it? Yeah. We're going to prove that they're the same thing also. Okay? Now, not the same thing as in what we just did, but they're equal to one another. Okay? We're going to prove they're equal to one another. I am going to recircle this. Oh, my. And I'm going to copy it. And I'm going to paste it, maybe. Okay. Okay, so we need A intersection B complement to start with. Okay, well, we'll probably need the intersection of A and B, right? First, before we find its complement. Okay, so A intersection B, who is it?
NBC and Fox.
Yep, NBC and Fox. They're the only ones. Okay, so if I want the complement of NBC and Fox, I'm going to write down everybody but those two from the universal set, right? So I'm going to write down ABC, CBS, USA, TBS, TNT, and MTV. Okay? That's the first one. That one was actually pretty easy. See, you're getting where you can see them without having to scratch around on things. You're moving things around good. Okay, the next part, I need A complement union B complement. Well, use your problem from before. We already found A complement and B complement, didn't we?
Yep.
Okay, so A complement, look back up at example 5, was ABC, CBS, TNT, MTV, and, did something happen?
I thought.
What happened?
Problem 5, it was intersect.
It was. It is, but we just have to know, we have to know A complement and B complement. That's all we're rewriting down. Yeah. No, it is the, like, are you talking about the A complement intersection B complement? Oh, no, you're good. You're good. Because sometimes like I told last class, I was like, if I make it to 9:55 today, because that's the 8:35 class, I said, if I make it to 9:55 without making a mistake in here, that's the first class I've made it through all week long without making a mistake. I did. I made it. Well, it's not looking too good for you guys for this one and the next one. I mean, you see me back to back. There's going to be some mistakes made. B complement was what? USA? TBS? And MTV. Good. Okay, now let's find the union of those. Whereas, like I said, last time we did do the intersection. This one should be the union. So I just write everybody down from those two, correct?
Mm-hmm.
Yep. ABC, CBS, TNT, MTV. Do I really not? No, I really don't have more room. Then I'm ready for B complement, USA, TBS, and I've already written TNT, and I've already written MTV, correct? Did I get the same thing? Please tell me I did. Or I've hit my mistake. They both have ABC, right?
Yeah, CBS,
They have CBS. They both have USA. They're not in the same order, but
TNT,
TBS, TNT, and MTV. Yep. So you showed that these two are the same as this second De Morgan's laws. Okay, you've proven the second set. Good job. Y'all are doing much better with this than one of my other classes did. It's because I get to see you so much. Okay, y'all ready? Okay, here we go. Example 7. Use Venn diagrams to show, we're still showing De Morgan's laws, so use Venn diagrams to show that A intersection B complement equals A complement union B complement. Okay, which one of those is of De Morgan's is that? First or second? Second, yeah. You can say this is second De Morgan. You don't have to write that on there. I'll just write it on mine. Second De Morgan. Okay? So, but this time it says use Venn diagrams. They didn't give us exact elements. Okay? They said use a Venn diagram. So that means that we're starting off with our rectangle universal set, and we got lucky this time. We only have A and B that we have to draw, which means I only have how many regions?
3,
Ah,
4.
4, good. Because I got 1, 2, 3, 4. And I get why you don't mind the 4 being in the bottom left-hand corner on that one, because he's not lined up with 1, 2, and 3. Yeah. No, it's okay. No, I get it. I hadn't thought anything about that. What I need to do is draw the box deeper so that 8 can sit lower. And I think they do actually draw there's more space in there, so it doesn't look like it's sitting flush with that 7.
My brain, it tries to keep the numbers in order.
Yeah, yeah, and it looks like when you do that, it looks like it's going right to left instead of left to right. Yep. Okay, so we want A union B complement. We got to show that it equals A complement union B complement. A intersection B complement, sorry, on the left-hand side. Okay, so let's think about it. If, I wonder if you can just, you know what? Here's the, we'll start off. A intersection B. Can you tell me who's in A intersection B?
2.
Yeah. So then who is A intersection, who's in A intersection B complement then?
Everything is left.
1, 3.
1, 3, and 4, right?
4.
And these are easier because there's not so many elements. I mean, a while ago when you were doing this, we had ABC, CBS, Fox, USA, and it was like, who am I marking out? You know, who do I need to not see and pull forward? Okay, so that's A intersection B complement. So now I need to do the union of A complement and the union of B complement, okay? So what's A complement? Can you just tell me? 3 and 4. A complement's 3 and 4. Good. I'm going to move this down so it stays in line together. Yeah, okay. What's B complement?
1 and 4.
1 and 4. Good. Okay. So then tell me what's A complement union B complement? 1? No. Yeah. Union. Keep going. 1. 1, 3, and 4. Because you wrote down A complement.
Oh, yeah. there's
You
2
wrote-
4s, okay.
Yeah, there's 2 4s in there, and we only got to write it one time. So did you just prove they're equal?
They are.
They are. You got 1, 3, 4 both times, didn't you? Okay, so that means that A intersection B complement does equal A complement union B complement. Good job. Check.
And that's whose law?
That's De Morgan's law. It's the second one. It's the second one. What was that, 7? Okay, 8. I know guys, there are 11 examples. I gotta get by 11:30. I got this.
Yeah. Piece of cake.
Piece of cake. Decide. Don't you love it when you get to decide? Oh, yeah, decide if the 2 sets are equal using Venn diagrams. Okay, I have B union A intersection C and A union B intersection B union C. That's a bunch. A bunch.
You got 3 circles.
Got 3 circles this time. Makes things not so happy. It's a little more complicated, but not bad. I'm gonna make this one. Okay. This one's a little harder to label, I know. A, B, C. Okay, so start at the uppermost top, inside the circles. So 1, 2, 3. Okay, now let's do those middle intersections. 4, 5, 6. That bottom chunk of the circle, 7. And then outside the circle at the bottom, 8. How about that, Kelvin? Is that better? Look. Is that better? Since it got more space?
Done deal. I already know where it's supposed to be.
Okay.
I put it there, I wrote it somewhere else.
That's okay. Just in your head, make
Put-
sure,
put
yeah.
where it's supposed to go.
Okay. Okay, so we're going to find, the first thing that we're going to look at is B, the first one, B union A intersection C. Okay, so what's B? We can sum that up pretty easy. What's B?
2, 3, 4, no,
2, 3, 5, and 6.
2, 3, 5, and 6.
2, 3, 5, and 6, right? 2, 3, 5, 6. Okay? And now we need a intersection C, right? That's the other part, the A intersection C. So we just want the intersection of A and C.
It's gonna be 4 and 5.
4 and 5. Does everybody see the 4, 5? Let me, okay, so I've got, pretty much, you're covering up B right here. And you're going, okay, here's A, here's C. Who's in their intersection? Well, who do they have in common? These two right here, 4 and 5. Okay? Sometimes I can get it to show up. Let me see. Here's A. Here's C. The green is where they overlap, because yellow and blue make green. It's kind of green looking. It's not great green looking. Is the overlap. So that's 4 and 5, right? For the A intersection C. Okay? And I'll erase that in the, well, let me, okay? So now I need, can I write my answer up there where I started? Is that okay? Can I go back? I shouldn't, because y'all go sequentially. So now I can find B union A intersection C. Because you got your two parts, right? We're looking here and we're looking here. And we want the what? The union. We want the union of it. So that's pretty easy. We just write everybody down, don't we?
Mm-hmm.
So I have 2, 3, 4, 5, 6. I wrote them in order. You don't have to. So I've got a 2, 3, 5, 6 from B. 2, 3, 5, 6. And then my A intersection C was 4. And I already have my 5. Okay? So that's...
The line goes in there as well. Like, no.
No?
You're looking at the line.
You good?
Yeah.
Okay. You're jumping ahead. Okay. Now, that's the first part, and it says decide if they're equal. So now we have to find A union B intersection with B union C. Okay, so that's like the title. There's the title. Okay. So do we don't yet, so we need to find, the first thing I'm going to write is A union B equals, okay, A union B, I write down what? Everybody that's in A and everybody that's in B? Yep, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? Then I need to write down B union C, don't I? Okay?
Everything except 1.
And 8,
And
yeah.
4. Yeah, and 8.
Everything but 1 and 8. 2, 3, 4, 5, 6, 7. Yep. Alright. Okay. And now you want their intersection, right? A union B, intersection B union C. Who do they have in common?
2, 3, 4, 5, 6.
Good. 2, 3, 4, 5, 6. So my question for you is, are they equal? Are the two blues equal?
Yes.
Yes. They are. Good job. Yes. B union A intersection C equals A union B intersection B union C. Look at what you've done. You did great. And see, just 3 weeks ago, if I had told you you were going to be doing stuff like this, you'd have been like, no, I'm not.
What kind of job am I going to have where I have to do
You not.
this?
See, I really can't post it now because I was like, you not. You taking this class because you need that credit because somebody, see, I really can't post now. I can't post this video
Or you
because
still recording?
it's still going. I'll have to chop that out. We got 10 minutes. What oh, 8, oh, 9, 10, 11. Oh, no. Okay, I'm going. If I run over and we finish it, then I let you out early because I ate up part of your break. So if I run over like 5 minutes, then you get out 5 minutes early because I'm eating part of your break, okay? Got it. You're sleepy. You're tired. Okay. Draw a Venn diagram illustrating the sets below. Okay, we're going to say draw a Venn diagram. I got to write it all out. Sorry. We're talking about cardinality. This is important. Draw a Venn diagram illustrating the sets below. Then use the diagram to find the cardinality of A, B, A intersection B, and A union B. Use the result to develop a formula for the cardinality of a union. This is actually a fun problem.
I don't know, cardinality, does that mean original?
No, now remember, we had a definition of cardinality. Y'all remember the definition of cardinality? If I ask you to find the cardinality of a set, what are you doing? Somebody remind me.
Anything the similarity.
Elements, how many elements are, you count the number of elements, that's all it is. So,
Okay,
cardinality is the number of elements in that set. So, yeah, we would just count them. And do you remember how we denoted them, how we wrote it? We do in parentheses, like A, close parentheses. So that would say the cardinality of A, and I'll show you. It's okay. All right, so we need to draw our Venn diagram, okay? And do I have 3 circles or 2 circles? 2, because it says A and B. So we got lucky. Because when we just have 2 circles, we only have 4 regions. Life is good. 1, 2, 3, 4. Oh, yeah. Okay. So it says draw a Venn diagram illustrating the sets below. Yep, got it. Then use the diagram to find the cardinality of A. Well, we write N of A. Remember, I would say, I told y'all that I would call it N of A, and I really should be saying the cardinality of A, but it's because I'm so algebraically driven that things like N of A come out because I say F of X. Yeah, I don't remember if I told y'all that story. We need the cardinality of A, the cardinality of B, so N of B. And then we need the cardinality of A intersection B and the cardinality of A union B. Okay? Then we got to write a formula, but we're going to come up with that. Guys, this isn't bad. If I want the cardinality of A, you're supposed to tell me how many elements are in A.
That's the problem. What you just wrote, the N.
Uh-huh.
That's the problem.
That's cardinality. That means
Okay.
cardinality.
Okay. But, I mean, that's the actual problem.
Yeah.
Okay.
Yeah. That's what all them words they were throwing out there. Their word salad just means find those things.
Yeah.
How many elements are in A?
2.
2. How many elements are in B?
2,
How many elements are in the intersection of A and B?
1,
And how many are in the union?
3.
3. You're 3/4 of the way done with the problem. You had to find these things too. You had to find these. You had to draw the picture. You had to find the cardinalities. And the last part says, use the result to develop a formula for the cardinality of a union. Okay? So they're wanting you to say the cardinality of a union, so A union B, is going to equal,
4,
3.
well, it does equal 3, but you need to write that in terms of the other cardinalities. So what you need to do, we've already used the 3, right? So using 2, 2, and 1, and using plus and minus in there, make 2, 2, 1 with some plus and minuses equal 3. Gotta use 2 2 times and a 1 once. And use some plus minuses in between them. Make it equal 3.
Yeah.
Do it.
1 plus 2.
But you gotta use the other 2.
So it's 2 plus 2 minus 1.
Good. 2. Hold on. I wrote it in the wrong spot. So 3 is really 2 plus 2 minus 1, right? Okay? You're good. You're good with the numbers. 3 equals 2 plus 2 minus 1. We used all 4 of those numbers. You agree? We good? Yes. Well, who is 2, really? Well, one of the 2's is the cardinality of A, right? The other 2 is the cardinality of B. You agree? And then the 1 came from the cardinality of A intersection B. Ta-da! You just wrote your formula for the cardinality of the union. So look, you didn't think you'd do that, and you did it. Look at you.
No, we didn't do it.
Yes, you did. So what this says is, if they ask you for the cardinality of the union of two sets, then you're going to take the cardinality of the first set and the cardinality of the second set. Somebody's at your front door. You're going to add them together. That's okay. That's what my Ring camera sounds like. Somebody at your front door. You better tell them, leave. Push that button. Tell them, get away, Kelvin. We take the cardinality of A, we take the cardinality of B, and then you subtract their intersection. Okay? Because you can't just go, well, this set has two elements, this set has two elements, so the union is 4, because if you do that, you're double counting that intersection, because you're counting like the Roman numeral 2, region 2 twice. Okay? So, it just says if you want the union, add the cardinalities of the single sets together, subtract off the intersection. Okay? Is what it says. We missed, you know what, I could add 10 and 11 probably to 2, 4 tomorrow. I mean, next Monday. Or I could just write them on the...
Monday.
Yeah, this is due Monday.
And so we've got it.
Let me go ahead and finish. Yeah, you're right. I need to finish example 10 and 11, and then y'all can take a break. I'll just let you out early, because I will. I'll let you out early. Okay? Kelvin, somebody wants you to answer the door.
Oh, my daughter's going in and out.
Oh, okay. It's some kids. All right, example 10. Draw a Venn diagram. That illustrates our formula for the cardinality of a union using the sets below. A equals A, C, F, G, L, K, M, N, P. B equals G, L, M, O, Q, R, T, Z. Okay, so you're actually using elements this time. You're not just using regions, you're using elements. So they want you to draw a Venn diagram using those sets, A and B, that will illustrate our formula, okay? And we'll rewrite the formula again, okay? So start off doing what you know how to do. It says draw a Venn diagram. Okay, well, and we have two sets, so that's my rectangle with only two circles. All right. So we have A, we have B, but this time there are elements that go in A and B. We're not just labeling the regions. Now the easiest way to do this, guys, is to fill in the intersection first. And this is a lead-in to 2.4 because we do a lot of these with actual elements in it. And the easiest way to do it is you go, who goes in the intersection first? Okay, that's what you do. You write in who's in both of them first. So who's in both A and B?
GLM.
GLM? Is there anything? There's a G. There's a L, there's a M, G, L, M, right? I don't have an A and B. I don't have a C, F, K, nope, N, and P. Okay, now once you have the intersection labeled, then you can just add the other stuff on the outside. Notice I marked out the G, L, and M from both sets because I've already put them in there, okay? So in A, now I can go in and write the A, the C, the F, the K, the N, and the P. Over in B, I can fill in its other parts. O, Q, R, T, Z. But see, that way, if you do the intersection first, then it keeps you from having to erase over here and then put it back over here because you wrote it, and then you don't accidentally write it on the side part of A and the side part of B if they both contained in there, okay? Write in the intersection first. Make yourself a little note. Write in. Let me put this at the bottom. Write in the intersection first. Okay? Okay, so we want to prove our formula of, and what does our formula say? That the cardinality of A union B is going to equal the cardinality of A plus the cardinality of B minus the cardinality of the intersection of A and B. Yes, you can. Okay. And just start writing in the numbers. What's the cardinality of A union B?
G-I-M.
No. A union B.
Okay.
And cardinality. So I'm going to need a number. That means how many elements are in A and B together? All together. You count all the letters.
14.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Why do I think somebody got 13 the other day? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, that's 14. Okay. All right. What's cardinality of A?
6. No,
Mhm.
9.
9. Good. What's the cardinality of B? Yep. And what's the cardinality of the intersection? 3. Does 14 equal 9 plus 8 minus 13? Well, 9 plus 8 is 17. Minus 3. 14 equals 14? Yep, you just proved it. That's what you were supposed to do.
The N is too busy. Depending on where it is, it means something different. It's cardinal on the outside,
Mm-hmm.
and then it's intersection on the inside.
No, that's not really an N on the inside.
What is it?
Intersection of N. It's just an upside down U.
See, that's even worse.
Okay, example 11, last one on here. If you don't want to, okay, I'm gonna chop it up because it's a long word problem, and I'm gonna chop it up. They polled 200 doctors. Okay, polled 200 doctors. Out of those 200 doctors, they found 112 had registered nurses in their office, okay? Registered nurses helping. That's what it is. There were 112 of them, okay? In 112 offices, those doctors had only registered nurses helping them, okay? Then, in 83 offices, they had nurse practitioners. Okay? So, they looked at 200 doctor's offices. Out of those 200 doctor's offices, 112 of them had registered nurses helping. 83 offices had nurse practitioners helping, and 21 had both.
A, B, and C.
AB. The doctor's offices is the universal set. There's the 200. A is the registered nurses. B is the nurse practitioners.
Oh, so.
Both is the intersection. The intersection. Both RN and NP nurse practitioners, there were 21. Okay? It wants to know how many were assisted by at least one type of nurse. So pretty much it's asking for the union. Is what it's asking for. The cardinality of the union. Okay? That's what it's asking. So let's draw a diagram so you can kind of see what's going on here. So the big universal set are the 200 offices of doctors, the 200 doctors' offices that they went into. And so you've got two sets, A and B. You've got the registered nurses and you got the nurse practitioners. And yes, those of you that are going into healthcare, I'm very well aware that in order to be a nurse practitioner, you first have to have been a registered nurse. You got to be an RN to get to be a nurse practitioner. You have to have a BSN, Bachelor's of Science in Nursing, and then you have that Bachelor's of Science in Nursing, and then you get a master's degree in nursing, and that makes you a nurse practitioner. But we're going, if you're labeled nurse practitioner, that's what you count yourself as nurse practitioner. You don't count yourself as a registered nurse anymore. Okay, that's the setup on this problem. Okay, now I told you that the easiest thing to do, the easiest way to start this is to label that intersection first. So how many of what goes in the intersection? 21. Because there are 21 offices that had both an RN, had RNs, and had nurse practitioners working in there. Okay? 21. Now, it said, now let's see what goes in the rest of the RN set, in the rest of the RN circle. They said there were 112 registered nurses. 112 offices had registered nurses in it. Okay? But do I put 112 in there in the blank? No. What do I put?
Got to subtract 21 from 112.
Very good. I'm going to subtract 112 minus 21. 112 minus 21, right? Mm-hmm. How many does that give me? What? 91? So that big number is 91. Okay? I'm going to erase this out here, and I'll put it down. Okay, that's where we got it from. Just RN only. Just had RNs in there. We're 91. Okay, how do I find what goes in the rest of the nurse practitioners?
Same thing.
Same thing.
Subtract 21 from 83.
Very good. I'm going to say 83 minus 21, and that's 72.
No, 70.
Is it 72? No,
No.
62. Together we'll get there.
Eventually.
62, eventually, yes. 62. Okay. So it wants to know how many were assisted by at least one type of nurse. So you could have had two nurses, but you go in that category. That's why I put the hint at the bottom. You're looking for the union. Okay? So all we got to do is add them up, right? So 91 plus the 21 plus the 62. What's that gonna give me? 112, 112 plus 62. And that gives me 174. Now, you also could have done it with our little formula, right? Because we know that the cardinality of Rn and NP was going to equal the cardinality of Rn plus the cardinality of NP minus, I didn't leave myself enough room, equals the cardinality of, no, minus what? Minus the cardinality of the intersection. I still don't have enough room. Oh, I'm sorry, guys. Of Rn intersection NP. Let's see if it actually equals that. What was the cardinality of the RNs?
21 and 91.
So 112, yeah. What was the cardinality of the nurse practitioners?
83.
83. And then that intersection was 21. Yep. Their intersection was 21. So that gives me 195 minus 21, which does give me 174, which was what we got right here.